So my name is Katie Wilson. I want to welcome you to this panel. I'm the moderator, but basically the panel will be just great. And I want to go through my welcome overheads first. So first off, welcome. This panel is sponsored by NETS Virtual Organization, or NETS VO. It's sponsored by NSF. And we have a fabulous website at nets-vo.org. If you haven't checked it out, please do. Okay, housekeeping. We've got a lot of folks registered for this, which is fabulous. Please mute yourself during the panel presentation. So if you're not muted, we will shake our finger at you and mute you because we're hosts. If you have questions until we get to the official Q&A, go ahead and put your questions in the chat. We may not answer your particular question, but we will try and incorporate, if we have like 3 questions that are related, incorporate it into one, so we try to get it. We may call on you to ask the question directly, in which case, please then unmute yourself. And this meeting is being recorded and it will be archived on our YouTube channel. We have a NETS VO YouTube channel, which you can check out. If you happen to be in the overflow link, if we get to 300 participants, though, people will have to go to the overflow link. Send me email at skwilson@seu.edu with your panel question in the subject, and then I can do it. I have my phone here, so I'm looking for emails on that. Okay, so introduction. So I'm Katie, and Tanya Pham, Ms. Tanya Pham of Santa Clara University, we're your moderators. This presentation is part of the Sally Floyd channel, webinars in honor of the pioneering telecommunications researcher, Sally Floyd. And now onto our panel. So I just need to go there. Okay, so our panel is, these are folks who really need no introduction. So I'm just going to say their name and you all can go ooh and ah, because I'm very excited that they're here. There's Vinton Cerf from Google, Alberto Leon Garcia from University of Toronto, Jennifer Rexford from Princeton University, and last but not least, Amin Vadat. And for those of you entering, please mute. So with that, I'm going to hand it over to our panel, and I'm going to stop my screen sharing. And I'm going to ask each of them, and I'm going to point to them and say, please just say a few words to start. So I'm going to point to Jennifer first.
Thanks, Katie. First of all, it's just a pleasure to be here. And I know the last couple of years have been really difficult for all of us, but at least the internet's here for us to meet in this way. And I look forward to seeing many of you in person soon.
Okay, and then in my next up on my is Vint Cerf from Google.
I took some notes already, and I had a list of things that I think we should pay attention to. But I think this was just that was not your purpose, unless you want me to rattle on for a minute or two on things.
That's fine. Go ahead. This is your time.
Oh, okay. Well, in that case, first of all, I note that there are 2 people from Google here. I don't think that there's anything evil intended there. It just happens that Amin and I have interests that cross into the territory of this discussion. Here are some examples of things that I think we should be paying more attention to. One of them is multi-factor authentication. And the thing I worry about is that I have 300 accounts and I don't want 300 little, gadgets to stick into my USB. So I want something that handles all of them in a smooth way. Second, we never really managed to take advantage of broadcast communication, radio-based communication in the Internet Protocol Suite. And I'd like to see some attention paid to that. Third, I screwed up and did not get mobile operation right. When you move around, you could change your IP address. The trouble is that when you do that, it breaks the TCP connections. The QUIC protocol does a little better at that. If one side breaks, but the other one doesn't, or changes its IP address, you can actually recover from that. But more attention should be paid to mobile operation and the making and breaking of reassembly of connections. I think we're also starting to see something in the computing world, heterogeneous computing. Instead of everything being RISC-based, now we're starting to see specialization with TPUs, for example, and GPUs and so on. I think there are implications there. They may not be so much network related, but they're certainly related to compilation and creation of operating environments. The fifth thing is delay and disruption tolerant networking, which is the key element of interplanetary communication. And that's now literally heating up. We're at the point now where these kinds of protocols are going to be needed as we return to the moon and then go on to Mars. And so I'd love it if the internet world would start looking at problems associated with high latency, high and variable latency and disruption. And finally, get the hell on the stick and get V6 implemented so we can just get through this stuff, all this silly gray market selling of IPv4 addresses for $50 a pop. Of course, I'm a bitter old man because when I was at ARPA, I should have set a /8 aside for myself, which I would then sell, and that would be my retirement plan. But I was too stupid to do that. So let's just get this over with and get V6 implemented. Okay, and rant.
Okay, that was a great rant. And now I'm going to move on to Amin.
Thank you very much, Katie, and thank you to you and Tanya for organizing this wonderful panel. It's a pleasure and a privilege to be here. As Jennifer mentioned, I think that this is actually a testament to the power of the internet that we are able to get together under pandemic conditions like this. My children asked me, what if we had the pandemic 20 years ago? Right, and just imagine what a society and from health to communication to work would have looked like if we weren't where we were at. So it's been a tough few years for, I imagine, all of us, but also I think we do have a lot to be grateful for, and I think some really great learnings. I think there's a ton to talk about on this panel, but maybe building on that, society is running on the internet. That's just incredible. I mean, who would have thought? Certainly, when I look back to when I got my first internet account in 1988, when the first worm, at least I believe it was the first worm, hit, I was a freshman sitting in what was called the web workstations in Evans' basement. Evans was the computer science department at UC Berkeley. So it was a different web than what we're familiar with now. But sort of a third of the internet going down was, I think, fourth page news, 1-inch column in the San Francisco Chronicle, which, remember, there was newspapers delivered back in 1988. So much has changed, but imagine a third of the internet going down. That would be catastrophic. We had a taste of this with some of the cloud providers starting to suffer outages. And it's not about GCP versus AWS versus Azure. The most recent one was AWS, but I can tell you, I certainly took no pleasure from it. We started saying, hey, I can't get into my house. We can't sell things. And this is in 2021, 2022. The rate of reliance on the internet is just going to be going up exponentially. So what I want to call out, there's a lot to talk about, but the reliability of our infrastructure is just tantamount to society. And we in this community just have an awesome opportunity, but also kind of a scary responsibility is the way I put it, right? Because on our collective—
Recording in progress.
Yeah, so right. On our collective shoulders, we have a chance to, I think, advance societal capabilities. Our response to the pandemic is probably one example of that. But we also have the responsibility of knowing, one bad outage could cause catastrophic problems. The internet is a marvel. There are some weaknesses. I'll call attention in particular to DNS and BGP as two of the things that perhaps I'm most worried about. And at the same time, we do have this outsized responsibility in that the network failure will be noticed first, and is also most likely to cascade and spread to other components of this global computation communication infrastructure that we so heavily rely upon. So lots of opportunities, lots of responsibility. I look forward to talking through some of those here.
Okay, fabulous. And so now, last but not least, it's Leon Garcia.
Yeah, okay. I also had my little list. I was saving it for later, but I'll share it now. I think the top of my list, and addresses some of the items discussed earlier, was integrating intelligence in infrastructures. And I see networks as just a special case of the many intelligent infrastructures that are evolving. There's road networks, there's public safety, there's grids. And I see that if we do the job right in terms of building intelligence to manage networks, that we can use these in these other areas. So that's top of my list. The first target for this kind of intelligent infrastructure is to reduce carbon footprint. So really deploy the monitoring, the analytics, the response systems to be able to influence how users consume electricity and the carbon that's inherent in different parts of electricity. How to do that? To me, that I'd love to be able to at least contribute to that. One, in terms of, it was alluded here in terms of planetary networks, there's new modes of connectivity. These include drones, high altitude platforms, many new types of satellite systems. And these are quite dynamic in their attributes. And there was a neat thing introduced in CCN, content-centric networking, which was that strategy layer that was able to select which facet you were going to use. And I think something like that for these new types of networks would be really interesting to develop. I'll stop there.
I just want to jump in on one point Amin mentioned. First of all, I agree completely with Amin that the reliability of the infrastructure is really critical, and we're really responsible for that. Is that the emergence of sort of 5G, 6G, and next G networks really puts out an even sharper focus, both because the technology is super complicated, right? Is combining wireless communication, computer networking, and cloud, but also because it's going to be used in ways that are very novel in terms of cyber physical systems that are going to rely on the network to be able to drive a car or fly a drone, and so on. So I think there's an extra heightened responsibility there, and it's a really hard space because I think very few people are expert in all three of those areas. Usually, we're lucky if we're an expert in one of them. So I think that's an area that needs a lot more attention, and I think also having the infrastructure be more programmable so that when we get better ideas about how to have performance or reliability or security improve, we're not as hampered in deploying those new ideas as we tend to be historically. So I think those two things go hand in hand. If the network's more programmable, we can learn quickly how to make the network more secure and more reliable, and hopefully have an easier time deploying those ideas in practice.
Okay, well, Vint has his hand up.
Yeah, I wanted to react to Jennifer's comment. First of all, be careful about programmability. There was some experimentation done at ARPA with dynamic networks, and we discovered that they became quite vulnerable. So we should be very thoughtful about that. Although the attraction of P4 and SDNs is very clear, and I'm not against them. I'm just concerned that we be careful. With regard to 5G and 6G, which is undefined, but let me take 5G. There's a lot of push there for low latency and specialization and slicing and so on, all of which has a certain patina of attraction to it. The problem I see with that in the internet context is that 5G and 6G are not going to be the sole bearers of internet packets. And so it's historically been the case that in a single network, you can do all kinds of things to offer specialized services between pairs of communicators. But when you start getting multiple networks involved, it gets much, much harder. And that's why historically the internet has been a best effort system, because no one's really been able to come up with an end-to-end thing which works for everybody in between and deals with business models and questions about priority and replication and so on. So my worry about the 5G, 6G mantra is that people will imagine that the entire internet will be seen through that lens, and they'll have expectations that won't be satisfied by, for example, Wi-Fi variations and things like that.
Oops, I mean, you're muted, hon. You're
We
muted.
can't hear you.
You know, I saw a T-shirt the other day, and in the small downtown close to where I live, and the T-shirt said "You're on mute," and I think that that's the one of the most common statements on the internet in 2021 and 2020.
And I'm going to apologize real quick and say I'm going to go check the live stream because there seems to be a technical glitch. So you guys are on your own for a few minutes while I check that out.
We'll try to be civil. I was
Okay.
going to respond to
No,
both.
we can gossip about Kate. I mean, take advantage of this. I'm sorry, go ahead.
Respond to both Jen and Vince. And first, I wanted to give a shout out to Jennifer in that I think that her pioneering work really started the current movement towards software-defined networking. It was an inspiration to me and I think my teams in a lot of the work that we've done over the past decade plus. But I think that the tension that Vince and Jennifer are responding to is really, really interesting. I'm a huge proponent of programmability in networks, maybe not surprising. I think we need it if we are going to not have an ossified internet, one that basically, for reliability, we don't change. We know from experience that the best way to have a reliable network is to not touch it. We see this again and again and again. Don't change it, don't change protocols, and it's going to be pretty darn reliable. At the same time, it's not going to evolve. It's not going to meet our needs. So I think that actually a massive challenge, Vince and Jennifer are pointing to this right now, is how do you have programmability in the network? How do you have evolvability in the network while maintaining safety? And this is super hard. Like you can imagine that if you have this infinitely programmable, instantly programmable global network, one security miss and really, really bad things can happen. On the other hand, if you can build your programmability from the ground up to be verifiable, secure, distributed, et cetera, I think some really great opportunities come together.
Yeah, you hit on a key point at the end there. I mean, when you said verifiability, I think that's the key point. And those technologies have improved dramatically over the past decade. I mean, partially Moore's law and partially evolution in the tools themselves. So I think there's hope that we're a specialized enough environment that we can leverage good techniques from verification and programming languages to at least make sure that we don't shoot ourselves in the foot on a regular basis through the programmability of the infrastructure. In short, Vin, I agree with you. I just think it makes the technical challenge for us to solve to make sure we can use the technology safely.
We might take advantage of the chat here. Questions come up about web and Web3, which I consider to be kind of a marketing term. But it is important, I think, to distinguish the underlying internet infrastructure from the World Wide Web, since most of the World Wide Web lives in the edges of the network, which is where it belongs, in my view. I'm not quite sure, though, what to do about the way in which the web is changing. So maybe we could get, Ankit is the one that is it. Yeah, Ankit asked the question. The question is, what's happening, and is Web3 a real term, and what does it mean? And I don't know. I don't have a good answer to that, but maybe the three of you do.
I can start. Would love to hear from others, and of course also keep the chat going. There was about 20 years ago when it wasn't called Web3, it was called peer-to-peer, and that was all the rage in terms of decentralization across the internet. And I think that actually, to me, if I look at blockchain protocols, a lot of it came out of the work that took place 20 years ago. So maybe another shout out to that community. If we look at protocols like Cord, CAN, Pastry, and related, and then put Byzantine fault tolerance, which was really coming together around 20 years ago. You don't have to squint too far to see blockchain and then non-fungible tokens and related. So I think the big thing that's happening right now in terms of what happened about 20 years ago at the same time was a move towards centralization. The move toward the cloud, the move toward logically centralized control. And these things amazingly seem to follow 20-year cycles in my mind. So I think that we've probably come to the, if you will, logical conclusion of this 20-year cycle in centralization, partially driven by requirements of reliability, and also partially driven by the needs of sovereignty. What I think the world as a whole is saying is, do I really want 3 companies or 5 countries controlling the internet as a whole. And I'll speak not as a Google employee, but as a private citizen. I'd say the answer is no, personally. So I do think that there is this sweet spot between centralization and decentralization. I won't pretend to understand all the basis for, let's say, blockchain, and especially as it's applied to cryptocurrency. I still don't understand currency, period. Forget cryptocurrency. I've tried actually over the years, but that doesn't. There is some basis of trust that goes somewhere that I don't fully comprehend. So maybe is your question, is Web3 a thing? I think it is. I think it's there's a little bit more hype than I would like in certain places, but I think that in terms of implications for the future of the internet, this is probably a big shift that we're probably 3 or 4 years into. I think the big driver for it is going to be reliability, actually, rather than some of the other things that we're seeing.
I'd like to react to some of what Amin just said. Actually, I think it was around when BitTorrent was really taking off that I had a project that I called P2P control plane. And of course, the telco guys didn't want to talk to me because P2P was a bad word. But recently, we kind of come back to that. We're looking at the service-based architecture for the 5G control plane. And I was saying, can we make this, can we decentralize this? I actually have a student working on that. And that comes back to the question about the blockchain, whether you can get distributed trust and make these kind of service-based systems safer and more reliable. So I think there's interesting possibilities there.
Well, first off, I want to say I'm back, and I want to know if you talked about my scandal of 20 years ago. And secondly, I note that you guys have been using the hand raising thing, which is fascinating for me, because the past 2 panels were FileLayer based, and FileLayer people don't use the hand raise. So I think it's great that people at the internet level do use the hand raise, like protocol. Okay, so Vint, go ahead.
Well, gosh, there's so many things to comment on now. The first thing that I worry about is that there are reasons why you see concentration in the internet today, and they have to do with economy of scale. 2 examples of this are building services, online services, turns out to scale pretty well. If you look at the Google data centers, they just keep getting bigger. And the automation allows a large data center to be managed by a smaller than linear number of people to keep it running. So there's an attraction to that. There's also just the physical operation and maintenance is made better by this concentration. However, you notice we also replicate the data centers, and they're scattered around the world. Now let me give you an example of something that's going to inhibit that. There's a term called data sovereignty that's coming up, which some people adopt from the old, 1648. Gosh, I'm sorry, I'm drawing a blank on the name of the Westphalian peace treaties, which led to the idea that you draw a circle around a country, and whatever goes on inside is your business and nobody else's. The problem is that people are trying to adopt that in the data world, which is really harmful because it makes it hard to move data back and forth across international boundaries, which means that the whole distributed data center idea, which is there for replicability of the data and reliability, is harmed by this data sovereignty idea. So I just spoke this morning to a collection of people from the US State Department on this topic, warning that that's the wrong place in the architecture in which to protect information. It's not the question of physically where it is, but what is the access control to it, which brings me back to strong authentication and cryptography as a way of controlling access. Let me just stop. I don't mean to take all this time, so I'm sure other people have things to say as well.
The chat is really zooming along.
The chat
really
is,
hard to keep up
are
with
there
it.
any questions that you think, wow, this is it? I have one as a FileLayer person. And this is sort of like, how much do folks at your level of the stack, right, way up there, need to know about the physical layer? And how much do physical layer people need to know about the upper layers, right? I mean, it's sort of like, can't we all just be friends? You know, can't we all translate? But what do you think about that?
I had a smart aleck answer, which was you guys have to get along, learn to get along together. And this came back to this strategy layer in CCN that I find really interesting. And it also ties in with this monitoring and knowing of state so that you can do things in a smarter way. So what I see the strategy, the physical layers becoming more intelligent, at least to the extent that they self-monitor and can advertise what their capabilities are. And the layer above, be it network or whatever you want to call it, being able to select dynamically amongst these. And if this can be done reliably, there's all kinds of problems you could solve.
Cool. Anyone
Yeah,
else on that?
Yeah, I'll just add, I mean, I think in a lot of settings, you can think about the layers separately. I mean, that is part of the beauty of abstraction, that we can make things work without having to understand everything. But increasingly that doesn't work. I mean, it's performance and security and privacy are certainly settings where things don't stay in their layer particularly well. You know, link layer retransmissions, buffer bloat, side channels, all of these are kinds of things where the lower layers matter immensely further up the stack for properties we really deeply care about. And I think in the other direction, certainly understanding what applications need and how they might be affected by things that happen at the physical layer matters a
Dobro.
bit too.
Okay.
So I think people who can think across layer
Rozumiem,
boundaries
jasno mi je.
are really
Jasno
equipped
mi
to
je.
be able to do really interesting work that wouldn't happen otherwise.
Da. Okay.
Okay, and reminder to please mute yourself. Tanya is busily muting people, but just in case, make it easier on her. So Amin has his hand raised.
Yeah, reacting to this question of the PHY layer, I'll say it's hugely important in both data center and wide area networking. Jen raised the great point of 5G and 6G. I know less about, but I can't imagine that it's any less important in that setting. So first, I mean, the breakthroughs here on both the sort of baud rate, if you will, but and its evolution are just stunning. I mean, to me, speaking as someone who many years ago got an undergraduate degree in electrical engineering, the fact that we could turn a light on and off a couple of 100 billion times a second and then not quit and detect what's going on at the other side, miles, hundreds of miles away, potentially thousands of miles away, is fairly stunning. And then with the wave division multiplexing, phase modulation, and everything else that's driving things is basically it's the backbone on which we evolve our internet deployments is really what it comes down to. And it drives a lot of the commodities of scale in terms of the massive build out the capacity. Again, we talked about what would have happened if the pandemic took place 20 years ago. Well, the internet would not have had the capacity to support audio, much less video, at the levels that we do today. So progress at the PHY layer is critical. I'll say actually as we move toward a more predictable, reliable network. Jen was mentioning link layer retransmission, and these sorts of ideas applies both within the data center and I would say in the wireless cellular space. They're going to be increasingly critical to deliver application predictability. So I think there's just a ton here. What I would say is I would love to have more visibility in terms of what things are looking like 3, 5, 10 years out at the PHY layer. To some extent, because you all do a great job of advertising how hard your problems are, I always hear doom and gloom. Like 3 years from now, that's it. One last doubling and we're done forever. I remember when I was an undergrad, modems were going to go to 56 kilobits per second, and that was the physical limit as determined by some god who I don't recall saying it. But somehow you all keep managing to break through again and again and again. So what and when and how much, I think looking out more than one generation would be really valuable to us at the, let's say, upper layers.
Okay, Vint has his hand up.
So this actually it raises an interesting question, because over time we've increased the bandwidths of virtually all of the underlying carriage systems, but they are not all uniform. They don't all run at a gigabit, but they all seem to get faster and faster. One of the things about the original internet concept was that it was a multiple network system, each network having potentially very different characteristics. And the question was, how do we make it look sufficiently uniform so that everyone could reasonably expect to communicate from point A to point B, regardless of which network or networks you had to go through. If you want to start distinguishing among the capacities, I don't mean just bit rate, but other features of particular networks on an end-to-end basis, now you have to start paying attention to the path that the packets are taking. We attempted to do multipath routing where at one point where you had different policies, for different routes. And that got very complicated. We already know, and it's been mentioned in the chat, that BGP is one of the places where security and reliability is at risk. Adding more to BGP, to do multipath routing and everything else might be, well, I don't know whether or not that will turn out to be a feasible way of accommodating variations in the underlying system while also trying to create commonality that achieves the end-to-end result that we're looking for. But maybe exposure of more information about the state of the underlying network could be helpful. I just worry a little bit about how much information you can get and how old is it, how fresh is it? Because if you start to do control on information which is old and out of date, you get really, really bad results. The control theory tells you that you'll get in trouble.
All right, so I have another question, and then I think we might throw it to all the questions in the chat, which is, and this came up in our early discussions about, and you mentioned it earlier today also, is the ethics of the internet, right? We see a lot of good things, just like with any technology. There are good things and there are bad things, and personally, I think it's how people use it, but it's like letting the genie out of the bottle. So, any thoughts on that?
I have been ranting on this topic for quite a while now, and the rant was triggered originally by a lot of concern for machine learning and artificial intelligence, and many of us have seen efforts, including at Google, to fashion principles that would avoid abusive use of these technologies. But my belief is that we shouldn't be confined to machine learning as a concern. I think all software has a hazard associated with it, which is a function of the degree to which we depend on it. And as an increasing number of people depend on the software, then the hazard goes up. And so there are two pieces about this. One is buggy software. We got to find a way to write software that's less buggy, expose the bugs before we release them, provide means of fixing the bugs when we discover them after they've been released, as the recent logging phenomenon has illustrated. So I think we need to work harder to make the software less vulnerable. And I think the ethical thing is we shouldn't be releasing software that we haven't been more careful about assuring the safety and reliability of.
Yeah, I agree with everything Vince said. I'll just add, I mean, obviously the pandemic has put the digital divide into sharper focus, and I think it's incumbent on us to make it easier for people to roll their own networks and to lower the cost of building and running a network. We've reached the users that it's economically viable to reach, or at least a large fraction of them, and reaching the next set involves lower cost and easier installation and management. And with, prices have been going down for equipment, and there's more open source software, but there's still more to do to make sure that people can combine those parts together into something that really meets their needs or their community's needs.
Anyone else?
Yeah, I'll jump in. This is a great question. I mean, I think that's when we talk about the ethics of the internet, you could look at it at all levels of the stack. I think maybe if we want to talk about it at the communication layer, I have lots of worries at the information level that's carried across the internet, but maybe that's not the topic of this panel. I think at the sort of internet level, the fair and equal access is a really great point. I saw in the chat stream someone correctly point out that the basis for the internet was decentralization as envisioned by Vint and others. And that's certainly what drew myself, and I imagine many others, to networking and internet research. I mean, the beauty of it all is pretty stunning, right? Imagine being able to take a global communication network, attach anywhere you like to it, not know anything about it really, exchange a few packets with your neighbors, and all of a sudden you're a full functioning member of the global internet community. Pretty stunning and beautiful. I mean, the protocols that enable this I still actually and literally get shivers to this day thinking about just how beautiful this is. On the other hand, the bar has gone up substantially. So Vince said, hey, there are ethical concerns about releasing buggy software. Well, I'd say 30 years ago, it was a lot easier to release software than it is today. Right, the bar was just a lot lower, and it was a lot easier to get a quote unquote right. Software today, I mean, it is really, I get shivers in the other direction at what it takes to release what seems like relatively simple software and make sure that it works in the context of the billions, is it trillions of lines of code that run internet protocols today? Really, really hard. And so, and this goes back to the point we were having about programmability and verification and really getting to a place where we can actually have that low cost attachment points to the internet. Well, it's not that the devices themselves need to communicate to basic internet protocols need to be that expensive, right? That's probably not the hardest part. The hardest part is building them to be secure, robust, reliable, unhackable in a global environment. You all have heard stories probably of the botnet of 1 million webcams that have been hacked, right? And now are mounting denial of service attacks. And is there any equivalent of the Underwriters Limited that says, here's what it takes to connect to the internet? Maybe there isn't, and if there were, how much more complicated would it be to extend the internet? How would we remove the democratization and the rate of evolution, etc.? So anyway, I'm probably going on too long, but I would say the ethical concerns are real, but the economic considerations in addressing those ethical concerns are also daunting, in a global network.
Al, do you have any thoughts on that?
I'm not sure I want to bring up the privacy question. So maybe I'll set it aside. I did want to react to something that Henning had asked earlier about the outages, and it kind of came back again in terms of, can there be a fire department for the internet when something goes wrong? And I believe it's possible, or at least we should try. Okay, in the context of ISP failures, loss of service for a service provider, I was involved in a project where we measured the net flow from all the BRASs to all other points in the internet. And what we found was that for a large service provider, the traffic patterns are quite predictable and steady. They change gradually over a period of a few months. So you have to retrain and tweak it, but it's reliable enough that you can tell when there's loss of service. And you can do it right down to the level of Google service or Twitter or whatever, okay, by looking at port numbers. This is just net flow. And so that allowed the service provider to be able to detect loss of service before their customers started complaining, and they were delighted about that. So I think that this process of and the analytics involved were relatively simple, not fancy ML, relatively simple. Now, I think that for the internet as a whole, this might be possible, whether you require ML or analytics, I don't know, but definitely you need the ability to monitor the right things, okay, and continuously do inference on these streams. And based on that, I think you could build a fire department, or at least try. So that's my response to that comment on the chat.
And Vint had his hand up.
Well, let's see, there are a lot of things in the chat, and I can't handle all of them at the rate that they're coming in. One person that asked whether we had considered, these special features of the underlying physical layers. The answer was we did our best to ignore them. And even fought battles. At one point, some people were claiming, well, the Ethernet means that we should reformat the packets in a special way to make it all more efficient. And I battled against that because I didn't want the system to be dependent on any particular physical layer properties, because I wanted it to work for all possible physical layers. So that's in response to that one. I want to reinforce Al's point about measurement and monitoring. It's enormously valuable to know what's going on in the system. We do this at Google at all layers in the architecture. We're intense about this. And it's really important because you know when you've been reporting to another user that something broke, we know that we told somebody you got an error. So we can track stuff like that and say, hey, our error levels are going up beyond where they should be. So everyone should be paying attention to that. I noticed that Dave Tott is on the call, and of course he's been a huge proponent of the buffer bloat problem, which is a persistent problem, and we don't understand why we're not getting more traction to do better design, because it's a very clear phenomenon that we know how to deal with. So if I were making a list of things that we should do, that's one of them that I would add to the list.
Okay, so there are some questions that brought up this thought, which is there are things that we did 20 years ago that we don't do now. And what I'm going to ask is, what techniques from the past do you wish people would use now? And what techniques from the past are you pleased with? And what would you like to throw away? And what do you think is a good technique now that we didn't have 20 years ago? That's sort of a broad question, but just sort of then and now. My bad example is that my signal processing friends, some of them scoff at ML. They say, oh, that's just signal processing on steroids. I don't need to learn about it. But of course it's different. So what do you all think?
I'll jump in there. I mean, there's a broad class of things that were explored a number of years ago in the interdomain setting that never really took off. You know, multi-domain QoS, multicast, security, multipath routing, et cetera. And I think they were hard to deploy because thinking about getting, tens of thousands of networks to agree was just too hard. But in a lot of settings now, we just have a pair of networks between the content and the eyeball. And so I think there's an opportunity to go back to those systems and make them simpler to work in a setting where it's just a pair of domains that need to cooperate. And we might get much more traction now because the internet is a lot flatter. Not everywhere, but there's certainly a lot of settings where it would be just two networks cooperating to make something interesting happen.
So, let me challenge Jennifer's flatter thing for just 1 second. And thinking a little bit about the investments that companies like Google and others have made, the CDN companies are building their own networks. And they're as quickly as possible jumping from the local ISP into a proprietary network. And there are several good reasons for that, one of which might be just getting somebody to a CDN distribution point quickly in order to reduce latency. Another one might be to increase safety, security, and reliability by jumping from the ISP space into the proprietary network backbone. The third one is that the proprietary network backbone may be running things that are not publicly adopted yet. QUIC would be an example of this at Google, and we've introduced that through IETF into more standard use. So there may be pressures in the current internet evolution that still lead to this kind of concentration. So that's one point. The second one, though, and the one which let's speculate about, is that when the internet was first being designed, as you know, this is back in the early 1970s, there was another global network that existed. It was called the telephone system. And it was distributed. It made lots of different parties created pieces of the telephone network. There were all kinds of standards. People had measurements for, signal to noise ratios and, how many lines did you need for how many users and so on. There's a very effective system. And then the internet came along and said, well, why don't we borrow their dedicated circuits and build something else? So the telephone system provided a scaffolding for the ARPANET originally, and then the ARPANET provided a scaffolding for the internet. And so we might ask ourselves, rather than trying to evolve the existing internet into something, what if we just said, why don't we use it as a scaffolding to build the next thing, whatever that turns out to be? And despite the fact that I'm heavily invested in the thing, I don't for a moment, argue that we should just keep it because it's there. That's why the interplanetary system is using a different set of protocols than TCP/IP, because the TCP/IP didn't seem to work very well with a 40-minute round trip time to Mars.
Anyone else want to take that one up?
I think an interesting question is whether internet today is a scaffold to the next whatever.
Yeah,
I think that's a really interesting question. I think when you look at all of the activities in terms of containerization, microservices, creating applications in that manner, I think, yes, right now we're using TCP/IP, but when you look at changes that could be made in the operating system with Linux and so forth, I think there's all kinds of possibilities as to something that we could build on top of this scaffold.
So the key question here, sorry, I didn't raise my hand, but it would be asking ourselves if
it's
we were having,
aloha.
yeah. Yes, thank you. Okay, fair enough. Let's see, who am I going to collide with next? As I listen to conversations like this, I imagine myself trying to write a paper saying desirable properties of the next evolution of the internet. And I kind of wonder what would be on that list of desirable properties, because the way Kate set this up, that we're talking about, what research should we be doing, for example. But that would be very much related to the properties that we would like to see the system attain. And so let me put in one deliberate grenade here. This content centric networking, I have never understood, and I've had lots of battles with people who seem to think it's wonderful. And my reaction is I don't see how it scales, because if the idea is that you want to represent which content is where, the Dewey Decimal System for the content of the universe is not necessarily going to work very well in terms of scale. So I don't know if anybody wants to jump into that particular possible branch of the future, but I'm count me skeptical.
Okay,
I want
Al.
to take a stab at that. we're trying. I think when you look at, you have to look at middleware. You have to go to a layer above and see how it enables the next generation of applications, if you will. So I think when you start looking at PubSub and things of that sort, okay, then ICN, information-centric networking, starts making sense. Now, whether it can be made to scale or not is a question. It's always a question. We're trying using clouds, actually the AWS and Google Cloud and whatever's out there. We're trying to use that as a platform for deploying these kind of systems. So I think the jury's still out as to whether it can be made to scale, but we're trying.
Anyone else?
Yeah,
go ahead, Ben. Yeah, I'll let you take this one.
Just one tiny thing for Al. When you mentioned the CCN concept, I immediately started thinking about how broken URLs are, because if somebody doesn't pay for their domain name, then the URL doesn't resolve and access to the information is lost. Is the CCN idea a way of dealing with that problem?
You need alternatives to DNS. Okay, so depending on what flavor of news CCN variation you're working with, you need something DNS-like or an alternative to it. So there may be solutions to it. We're talking about that. I'm tentative because I don't know the exact answer.
I'm gonna dodge the CCN grenade that Vince lofted. I'll go back to Katie's original question, which is what have we learned over the past 20 years or so? I'll actually pick up the one that Alberto started, which is privacy. I think that actually this is a really serious problem on the internet today, and the internet makes it worse. The ability of let's say anybody almost to track activity globally is pretty easy these days, and the internet doesn't necessarily make it any harder. I think it's a bad place where, unless you have a true network expert, in your household, you're probably committing to exposing all you and your family's activities for forever. And that's not a great place to be. So we've learned a lot, I think, over the past 20 years in terms of what protocols and techniques we might use there outside of the internet infrastructure. I think it'd be great to apply some of those as a research challenge. The other thing I'll mention, somewhat related, is we've learned a lot about software as a service. So going back to DNS and BGP, what I would ask, and I've personally tried rather hard at Google to try to get BGP to a better place, for example. Some success. I would say we've moved the needle, but it's far from where it needs to be. What would we do to run, again, for critical societal infrastructure, BGP and DNS differently than we do today without requiring now I don't want it to be controlled by one company, to be very, very clear. I'm looking at the chat stream, but we do know how to distribute these things. But at the same time, how do we not rely on every network on the planet having to adopt a new thing, potentially requiring capital expenditures and new operational expertise that they might not have, to get the internet to a more reliable, secure place? I feel that we're stuck right now, but we do know how to do software as a service in a decentralized manner. Blockchain comes to mind as a possibility actually there as well.
Blockchain. I mean, you know, this is the 21st century Brill cream for those people who remember the 20th century jingle. Okay, and I don't want to have the blockchain debate necessarily, but I will say that there are some interesting possibilities with regard to the domain name system, one of which is to distribute the root so that everyone has a copy. So the caching resolvers actually get updates of the root, but they don't have to go find a root server in order to find the updates. That still leaves you with the interesting problem of how long does it take for a root update to propagate everywhere where it needs to be, because of the proliferation of things that are relying on it, as opposed to the several hundred servers that we have today, including the Anycast root servers. But to first order, that's one aspect of distribution that one could introduce, because now that the root is signed, it's possible to validate whether or not the data you got back is accurate or not. That depends, of course, on, by the way, this might also help with the problem of false information coming from domain name lookups. Although if the software itself in the thing you're relying on has been altered to lie to you, then not much can be done unless you're checking digital signatures faithfully.
I have a question, which is, if it's related to, what do you wish people were working on now that you don't see as much of as you would like? In other words, what problems are out there that you think, this is underserved?
Well, my first reaction to that is wishing that the researchers on software reliability would give more thought to the programming environments that people use to produce software. We don't get clued in to our mistakes as well as we should. And you know, you mentioned the 20 years ago. Let me give you 50 years ago. When you had to go to a data center and submit your deck of cards and get them run, and you didn't get them till the next day, I can tell you that we did a lot of desk checking before we submitted our runs to get rid of all the stupid little, you know, I missed a comma or I have a lexical error here. There was a lot of effort put into making sure that what we submitted was actually likely to work. And I know that I found a lot of bugs as a result of doing desk checks before I actually submitted my jobs. And once we got online stuff interacting, everybody would just run whatever they had into the system and let the parser figure out if they'd made a grammatical error. But I think it made people less careful about the code that they were running.
I agree with what Vince just said. I'll just add maybe more of a meta comment. I think networking is a domain with lots of really interesting practical problems that are constantly changing due to new technology and new demands. So we have a lot of nails, and there are a lot of hammers we can use from a lot of different disciplines to attack those problems. And so I think it's exciting when researchers bring a new hammer to there's been a lot in programming languages and verification recently. I'm sure there's lots of other hammers out there that could help us attack really thorny problems. And likewise, there's lots of new domains in which to apply them, whether it's satellite networks or home networks or 5G, 6G networks, et cetera. So mastering the domain details of a particular setting or mastering a particular disciplinary technique and wielding it effectively, either or both of those are always really exciting to help us get better traction on having a stronger foundation for the internet. And I'll just add on top of that, we often have this learning curve to going into these new disciplinary hammers and domain details. And so the people that do sort of heroic work to write books and survey papers and MOOCs and tutorials, do a great service to the community to help us hopefully get up to speed on technology that moves far too fast for any of us to keep up.
Amin has his hand up.
Yeah, so in terms of what I wish that actually the research community, I think that's what you were asking about, Katie, worked on a number of the problems that we've outlined here. But what you'll note is that most of them actually don't map to the hot topics that are being published in various conferences today. And that's because researchers, like I guess in this domain, myself included, love to know when they've done better, and hence they are attracted to the problems that are pretty well defined and that have quantitative metrics associated with them. And so in particular subdomains, we've done a great job of saying, hey, if you make your flow completion time lower than the last paper published last year, that was better than all the other papers, your paper is going to get accepted. Now, there's definitely room for that kind of research, and we should do it. And by the way, I do it, so I'm actually not necessarily pointing fingers. For example, I've been attracted to the siren song of congestion control protocols for 20 years and still love it. So we should do that kind of research still. What about privacy, let's say? What about reliability? These are harder topics to do research in. These are harder topics to say, well, you've made the 98 from last year become 98.4, and hence your paper is accepted. But so this is actually not just a call to the researchers, but also the program committees. How do we make sure that we encourage work that actually will maybe move the infrastructure, the internet as a whole forward? Because it's not clear to me that actually improving, speaking as a congestion control lever, improving congestion control by another 3% is the biggest problem that the internet is facing, even though it's maybe one of my favorite problems to work on intellectually.
And Al has his hand up.
Yeah, and it's kind of a question for Amin, maybe. We're talking about what kind of research needs to be done, and I think it's really important that we reduce carbon footprint of the technologies that we work in. Now, Google has been a leader in data center carbon footprint, and that's because it's a domain where they have the complete control. The question for Amin was, what can be done in domains where no one in particular has complete control, and yet that are significant emitters of carbon, if you will. Any thoughts?
Yeah, great question. And actually, this is one that I'm spending a fair amount of time on recently. And this also goes back to, I think Henning had a comment on this in the chat stream earlier. The one thing that I haven't raised in any way that I'm really excited about is internet research and network research as a cross-disciplinary issue that really cuts across storage, compute, hardware, data centers, et cetera, as a whole. And I think that that's a ripe area for us to be looking at, not just layers 1 through 7, bringing in 5, but okay, what about the servers that are connecting to the network? What about the applications that are running there? So your question is a really great one, multifaceted. I'll say the place that's maybe most ignored right now is the manufacturing cost of our equipment that we put into our data centers. Google and others, not just Google, are going to get to a place where the operation of our infrastructure 24/7, 365 will hopefully be carbon-free in the next decade or less, hopefully. On average, I think it's going to get there sooner, but now we're saying 24/7, 365 in all geographies at all times. So that's pretty good, actually. But I'd still say, what about what it takes to manufacture the infrastructure that goes into all these data centers, gigawatts being produced across the planet? Just building the stuff out has cost. So one, how do we get the same amount of work done with less compute network storage infrastructure? I think that that's a perhaps ignored topic. It's, hey, how do I get my bits per second through? But what if I'm sending useless bits per second? Does that, I hope that that's clear, right? What if I could get the same amount of logical work done while consuming less energy, building less capacity, et cetera, et cetera? And then how do I actually look at the hidden cost of manufacturing all this infrastructure as a key thing to optimize for? I think that the internet as a whole has a substantial role to play here, but it will be cross-disciplinary. It's not, it's as you said, it's not something that's even just a network layer thing. It brings in the whole ecosystem. So great point, and thanks for raising it.
Okay, Vint has his hand up, and then I'm going to Jennifer.
Okay, well, first of all, Amin is quite right that we're looking at an ecosystem here. We should treat it as a system of systems and understand that there are a lot of interacting parts. I wanted to pick up on one comment in the chat and also in our dialogue, and that's privacy and balkanization. The big worry I have right now is that countries that are worried about abusive behaviors on the internet are trying to build, boundaries around their countries at very low layers in the architecture. And that does lead to a kind of balkanization, although my friends in the Balkan states hate it when we use that term. So why don't we call it fragmentation to satisfy their concern? It seems to me that part of the motivation for this has been to somehow protect the information by concentrating it in a geographical location. And I'm pretty sure a lot of people would agree that it's not any safer no matter where you put it. So the real solution to some of this is to use strong authentication and cryptography as a way of content no matter where it goes. And so as long as it's protected, and I know there's been a comment in the chat that's saying more crypto is not the answer, but I actually believe that to avoid introducing the fragmentation of the net by trying to control where data goes at a very low layer, the better tactic is to control access to the information and give the ability to access it in a strongly authenticated way. So that's one area where I wish we would pay more attention. The other thing about congestion control, Amin, in particular, your perspective would be very helpful here. We're having a big challenge in high latency environments of the delay interruption tolerant network, trying to figure out how to deal with the congestion problem because we don't find out about it in a timely way. And so figuring out, are we congested and what do we do about it in those environments is turning out to be a big challenge. So that's a piece of research, presumably, because I certainly don't know a rabbit that can be pulled out of the hat.
Hey,
I would certainly agree that, so sorry
Yeah.
to interrupt, but congestion control with hour-long or more multi-hour-long control loops, that definitely sounds like an interesting hard problem that hasn't been super well explored.
Wow.
Great. So I'm going to go over to Jennifer, who noticed that there were a lot of questions in the chat about AI/ML.
Yeah, so I think that people are asking about the role of AI, ML, and networking. I'm certainly no expert, but two thoughts there. I think there's one area where for many years we've been designing protocols that try to learn about network conditions, whether that's congestion control or rate adaptation for video streaming or load balancing over multiple paths. And in those settings, we're starting to see some lovely work that leverages machine learning to solve those problems in a more direct way than sort of human ingenuity and coming up with those learning algorithms. So I think that's exciting. The second setting, which is the one I'm more interested in, is network management. And there, I think we've seen less success in using machine learning to do more than just sort of anomaly detection. And I think part of that, there's a great talk Jeff Mogul gave a few years ago on self-driving networks. And he sort of said, if you're going to build a self-driving car, you wouldn't start with the Corvair. Right, so you have an underlying network that exposes relatively limited information and offers relatively limited knobs for tuning. And so it's not easy to bolt ML on top of a system like that. But when you've got greater programmability and you can have the network expose the features you want and enable the knobs you want, it becomes a lot more natural to think of applying ML because you can design the system with direct visibility and control in mind, so that you design it so that it's friendly to having machine learning or other forms of learning added on top of it. Will it work? I don't know, but certainly without a better designed sort of dials and knobs, it seems very difficult for it to work for network management.
And for those who are too young, the Corvair was the car that was unsafe at any speed.
My wife had a Corvair, and I was terrified that she was driving around in Los Angeles with it.
So Al, you have your hand up.
I had a comment on the AI ML.
Mhm.
And both in terms of applications for network management and just applications in general where network supported, if you will. I think there's really interesting questions because when you start looking at the delay, the time constants associated with different kinds of loops, be it cyber physical system or managing slices, okay, that different kind of time constants call for different type of distribution of the microservices that constitute this control loop. So there's really interesting, it's kind of like a new use case in terms of you can talk about QoS. You can't really talk about quality of experience for ML, but you start looking at the deployment of the microservices or the network functions in a different way. So to me, it's interesting just because I've been working on QoS forever, and here's a new one. But anyway, so one is this kind of issue comes up in network management, but a question is if the network people manage to do it well, and to do this, they're going to have to leverage cloud resources. Can it then be offered as a service? Okay, so you can have AI ML as a service using joint network and cloud resources. So to me, these are interesting possibilities.
Vin has his hand up.
So let me respond on the AI ML part. And I mean, you may be able to illuminate this better than I can. I'm certainly no expert. But my sense of the current multi-layer machine learning mechanisms is that it is statistically based. It is ingesting into the system the statistics of a large amount of information. So as an example, the false face generation algorithm simply takes statistics from lots and lots and lots of faces and then generates faces that follow those statistics, even though those people never existed, but they look like they're real people because we simply borrowed the statistics of facial shapes and colors and what have you. So the reason I bring this up is that the machine learning tool isn't magic. It's very heavily dependent on whether the system you're modeling has stable statistics, first of all. And second, whether or not the statistics are drawn from a sufficiently broad source that you have a good model, as opposed to a partial model, which then fumbles when it's confronted with something that wasn't part of the original statistical training of the machine learning system. So I think we should be very cautious about assumptions of what ML can do for us, at least in its current state, because it depends so much on the nature of the data that and the system that we're trying to model. I worry about a network management tool that tries to use machine learning tools to make decisions if the network doesn't have stable enough statistics. And I think, Al, didn't you mention earlier on that there is a certain amount of stability in the core of the networks, less so at the edges.
Yeah.
But in the core interconnects, it's possible that these kinds of machine learning tools could actually be useful because of the stability of the statistics.
And the additional point I make is that you don't necessarily need machine learning as in deep neural networks and things of that sort. That advanced analytics, traditional but quite sophisticated advanced analytics can work really well. So it depends on what problem you have in front of you. You may need machine learning, but you may not. The big data aspect actually is also a big challenge here, in that if you don't do it right, it's going to cost you a lot to manage all that data. But if you do it right, it's doable.
And Amin,
Yeah, 2 points on AIML. One, responding to the nice points from Vint and Alberto here. Agree with everything that Vint said on sort of the importance of the statistical input. The other thing I'll note is the importance of debuggability for these models. What we see is that oftentimes the answers coming out of these systems are substantially better than traditional systems. But then when they're wrong, we have no idea why. So how do you debug it in the rare case that they're less good? The rare but important case, I think, is another key challenge. So you could imagine that from a even network management perspective, if 99.999% of the time you're getting better network management decision, but then 0.01% of the time you're getting a really, really bad one, might still not be the right outcome if you can't debug it on a regular basis. The complete left field, if you will, version of this, in going back to sustainability, is AIML is actually taking up a substantial fraction of global compute capacity today. Reliability there at a different level is super important because of the size of these models that are coming up. Imagine running in parallel on thousands of individual servers, potentially each with many accelerators, whether it's GPUs or TPUs. Checkpoint restart is a real thing. The amount of compute and networking that's associated with actually making sure that the computation that might run for a week at immense scale, let me put it that way, actually produces output at the end is substantial. So I think actually in the networking community, there's interesting things to be done to make sure that these large scale computations can be made reliable without pretty heavy weight. And I do I want to emphasize very heavyweight constructs for being able to recover from individual failures.
I wanted to bring up a related network management problem. Again, in the high variability DTN space, ping is not your friend in that environment because of the uncertainty of the response times. And so figuring out how to build a network management system that will work for something spanning the solar system is also turning out to be a big headache. We think we made some progress with it. The IPNSig.org is a place to discover some of that progress. But I want to draw attention to it because it actually is a hard problem. It's back to the whole control theory situation where old data is not your friend because it doesn't describe the current state of the system you're trying to manage.
okay. So there was a question in the chat about the ideal future internet versus what we have and what we can achieve. And one thing I've always noticed with communications is we always have to deal with backward compatibility. Like the 5 millisecond frame, lives on and on and on because we have to be able to go 5G to 4G to 3G and so forth. So what do you think about that, the constraints of future directions here?
Go ahead, Al.
Yeah, I'll start with a smart aleck answer again. There used to be 8 kilohertz, which was sacred with telephony, and that's gone. So given enough patience and time, things can be changed. So that's what I would say.
Okay,
Anyway, that's all.
of course, it depends on what country you're in because I think pot still exists in the US, but not in Europe. But there you go. Yeah.
Well, that's because pot is now legal. So let me come back to the let's say the innate resilience of things that work. And so we do get these long overhangs. For example, the 80-column card influenced all kinds of things for a very long time, disk track sizes, all kinds of stuff like that. 2-digit years instead of 4-digit years created the Y2K problem. And now there's a Y2038 problem that some of you may have heard about with the size of the clock in the Unix systems overrunning at 32 bits and causing everybody to think it's 1900 again. So there, these sorts of things do last for a long time. And backward compatibility is very valuable, though, for introducing new technology and bringing lots of people with you. The question is whether once you've introduced the new technology and its backward compatibility, can you get the people who are compatible with the old stuff to move to the new stuff? So you get to the point where you can say, let's not use the old stuff anymore because everybody has the new stuff. So that's a challenge for deployment.
Jen has her hand up.
Yeah, I mean, the one way to around this quagmire is an old idea, whether you call it network virtualization or slicing, so that you can have the old and the new side by side. Not only because backwards compatibility is hard, but it's also hard to satisfy all the design goals of all the applications at the same time. And so the ability to have, high security in one slice and high performance or high anonymity or et cetera in another is a really appealing notion. So not just for backwards compatibility reasons, but because we have such diverse needs, the ability to have multiple concurrent networks running together seems like a very important way out of trouble.
So if you were to start designing the internet now, with everything would it look like it does now, or would it be totally different? That's sort of my crazy question. You're muted.
Thank you. That must be the most common term in in 2021 and 2022 is you're muted. I think if I were to start over again, I would probably recognizing the space in which, I don't mean interplanetary space, or just the generic space in which network design is being undertaken. I think it would look somewhat different. For one thing, when I started in this space, I was thinking we didn't know what would need to communicate with what, so it should be possible for anything to address anything else. This is sort of an end-to-end argument that you should make it easy for anything to talk to anything else. I think what we're learning is that maybe that's not so wonderful, because that means everybody can be targeted by a denial of service attack or by a malware attack and what have you. Maybe the ability to address things needs to be more constrained than it is. I'm not sure what the implications of all that are. It certainly was convenient to say to someone, because of that assumption, no matter where you were on the net, I think Amin mentioned this earlier, no matter where you were, when you plugged in, you could talk to anybody, which meant that you could invent new applications for people who you didn't know, and you didn't know where they were and didn't care. It's conceivable that we would need to rethink that for safety and security's sake, for example.
Anyone else on that?
I'll jump in briefly. Actually, there was a whole spate of research and funded by multiple government agencies going after this question. A lot of great work came out of it in terms of what would a clean slate internet design look like. I'm a fan of a lot of it, but I think that actually we talked about how something might be invented layered on top of the internet. I think it's too early for that. I think that the backward compatibility question for me is more important and relevant. The internet's got a ways to go. It's got some challenges, but reinventing it clean slate, probably not in my opinion, I'm speaking for myself, probably not the time. How do we evolve it to where it needs to get to is more interesting for me.
So there was the Clean Slate Initiative was funded in part by NSF, and maybe DOE had a hand in it too, but Dave Clark was very much involved in that and wrote a book about how to design an internet. And so people who are interested in that question would be well directed to Dave's book, because he does a very good job of exploring what the design spaces could look like.
And Al.
Yeah, I was going to make a point about virtualization, but Jennifer brought it up. But I'll bring it back again, because my point is that the virtualization, the microservices gives you a lot of flexibility to try out. One of the points about calling for virtualization when it's clean slate, right before the clean slate activity started, was that virtualizing gave you a transition to possible new internets. And so this virtualization allows you to, it's not really an overlay, okay, but you can deploy new internets that are completely software based, that ride on existing technologies. And if they can prove themselves, maybe they should be considered as new internets. So there's more of an ability to experiment and try out now than there used to be 20 years ago before SDN and these other technologies.
Okay, I'm going to go to Jen and then I'm going to go to Vint on the quantum question.
Great. I mean, I think that the end-to-end argument played obviously a huge role in the early days of the internet, and it was important to the whole thing even getting started and being successful. But I think one limitation of it is now we see end hosts being network members in peer-to-peer networks and overlays, and we see network members that act like edge nodes, you know, in terms of middle boxes and so on. And so I think a more reasoned way of thinking about the division of function between edge and middle, and not thinking of that as synonymous with end host and network, would be a really useful way of rethinking and maybe generalizing some aspects of the current internet architecture in ways that are faithful to how it's actually operated and used today.
Okay, and Vince?
Okay, so let me try to respond to the quantum internet question. When I first heard about people talking about quantum internet, I sort of poo-pooed this as, oh, well, you know, people are all excited about quantum, so they're applying it to anything. It's just like add crypto or cyber to the front of anything, and suddenly it becomes interesting and different. But there is a serious issue here. Designing and building a quantum computer is a non-trivial exercise. We're doing it at Google, others are doing it as well. Scaling up to large numbers of qubits is actually hard and necessary, because in order for computation to last for a while, you need a lot of error correction. In order to do error correction, you need a lot of physical qubits to make a logical qubit, perhaps as many as 1,000 physical qubits for one logical qubit in order to maintain a computation long enough to get the result that you want. The implications of all that are that building big quantum machines is hard. So if you can build a lot of smaller ones and interconnect them somehow, so that you get the effect of quantum entanglement across a network, that's actually a helpful capability. But that means building quantum routers which maintain entangled information across distances and allow multiple quantum machines to become whose states to become entangled with each other. So quantum networking is actually a valuable concept, and one which might allow us to build useful quantum machines in the long run.
I just saw an amazing question from Licia Zhang. I know I'm mispronouncing your name. The panel asked a critical question earlier. What is the foundation of trust for Web3?
That's Licia Zhang. And
Licia Zhang.
Licia, yes, Licia is a longtime pioneer in this space too. And to be honest, there isn't any basis for trust. And this is sort of like Scott McNealy. Remember when he said there isn't any privacy, get over it? Yeah. I think we have a lot of work to do to find a way to build trust into the systems, which either was never there or which we lost. Maybe we were naive, but it's time to build real trust into the system.
How does one do that? I know that's a existential question here, but
well, there used to be these. Go ahead, please. Sorry.
Well, I think there are several things. One of them is the ability to exercise strong authentication. We've already discovered that certificate authorities can be broken, therefore certificates are not ultimately reliable. So what else can we do? There's been DANE, for example, which is to try to overuse the DNS to distribute crypto keys. I don't have a glib answer for you about how to rebuild trust, but I think in order to have any at all, we're going to have to be able to demonstrate sort of from the bottom up that we can have untrusted systems out of which we can derive trust somehow. And I'm pretty sure some of that involves end-to-end interactions, which are not, whose trust is not dependent on the lower level architecture.
Amin, your hand is up.
Yeah, there used to be these signing parties at various meetings, IATF and otherwise, around PGP. I'm sure Vince really enjoyed those. But I think the point is that trust, to Vince's point, is bottom up. It's based on pairwise, well, usually, hopefully, human interaction. We saw this as the basis for even search results and ranking, right? Who created a link to this page? A human being did. And if lots of human beings chose to create links to this page, probably for the content of that page, there's some trust in the veracity. My point here is that it's built up from the bottom among human beings who judge the quality of particular content or identities, etc. And it can't be a centralized authority, in my opinion, if we're truly going to get evolvable trust.
Well, we're starting to run out of time, so I thought what I'd do is go back to the four of you and see if you have any last thoughts. And I want to thank the audience for amazing questions, and I'm sorry if I didn't get to them all. And thank you for being here. So, Jen, you first.
First of all, thanks. This has been a fabulous discussion. I would just add that there's so much to do here, obviously, and I could just encourage people that are getting started to get their hands dirty. I mean, the more experience you get with real data, with real networks, with real protocols, real deployments, real users, real network operators, the more your ideas have a chance of focusing on the right problems and getting traction.
Vint.
Well, I certainly enjoyed the discussion. I would urge you to ask whether the participants would allow the chat to be shared. I really
Excellent
think
point.
there are some great ideas in there, some real, substantial questions that didn't get answered.
I was thinking,
So,
yeah,
so
I was
if
thinking
we-
about posting it if they don't mind.
I certainly don't mind, and presumably this video is being recorded.
Yeah.
So there's that. Anyway,
Okay.
thank you for inviting me to participate. It's been very
Oh.
stimulating.
Thank you. Amin.
I'll start with where others have been. Thank you. Really enjoyed this discussion. Would love to figure out avenues for how we could continue the conversation. The chat and the follow-up has been terrific. And I think we should also see about figuring out how we can make some of the discussion even more interactive in the future. But this has been fantastic. Thank you, Katie, for organizing this.
Sure. And finally, Al, last but not least.
Great discussion. I was going to request that the chat be shared. I can't read fast enough. They were coming in fast and furious. They still are. So it'd be really useful to be able to go back to that. But the other point, one point we didn't get to was how do you get students interested in this area? There's a lot of work to be done here. I started in ECE. I'm still in ECE, but mostly talk to CS people. But somehow we need to get students, young people interested in this. And I think software and math, that's the way I would push it, of course, but it's up to them. But the point being that we should make an effort of sharing this recording more broadly. I like it. I was thinking throughout the discussion, boy, I want my students to watch this. They're going to learn a lot. So that would be my suggestion. Thank you, Katie.
Subscribe to our YouTube channel. Thank you all.
Thank you
all. And I'm going to say goodbye. And I'm sorry if I didn't get to your questions, but I will work on saving the chat. All right. Bye all.
Bye.
Bye.